Have you ever stared into the night sky and felt a profound sense of dread? A feeling that something ancient and impossibly vast is staring back. We talk about the wonders of the cosmos, but what if it's not just wonder we should feel, but also a deep, primal fear? Today, we journey to the edge of understanding, to the most enigmatic objects in the universe, black holes. They are the ultimate cosmic monsters, a concept so strange it borders on the Lovecraftian. We see them as points of no return, but what if they are something more? What if they are doorways, not just to other places, but to a reality so fundamentally different from our own that our minds can barely grasp it? What truly lies beyond the event horizon, that one-way membrane in space-time? Is it an abyss of nothingness, or is it the beginning of a story that redefines everything we thought we knew about existence? Join me as we peel back the layers of reality and confront the darkness that awaits. Everything in the universe has a life cycle, a story of birth, life, and death. And for the most massive stars, their death is not an end, but a violent and spectacular transformation. When a star at least 20 times more massive than our sun runs out of fuel, its own gravity becomes its executioner. The core collapses in on itself with unimaginable force, crushing matter into an infinitely dense point of singularity. This is the birth of a black hole. But this birth is not a quiet affair. It's a cosmic scream, a supernova explosion that for a brief moment outshines entire galaxies. What's left behind is a gravitational predator. Anything that strays to close gas, dust, entire stars is caught in its inescapable pull. This material doesn't just fall straight in. It gets whipped into a frenzy, forming what we call an accretion disk. This swirling vortex of superheated matter glows with incredible intensity, a final, brilliant scream before being devoured. It's a chaotic ballet of cosmic destruction, a feast for the monster lurking at its center. And these stellar mass black holes are just the beginning. At the heart of nearly every large galaxy, including our own Milky Way, lurks something far more terrifying, a supermassive black hole. These behemoths are millions, even billions, of times more massive than our sun. Imagine our entire solar system, a vast and complex structure, being just a tiny speck in the gravitational domain of one of these giants. Looking at the intricate, sprawling web of a city at night, with its millions of lights and interconnected pathways, you get a sense of immense complexity. Now, imagine that entire city is just one small neighborhood within a galactic metropolis, all of it orbiting a single, dark, all-consuming center. That's the scale we're dealing with. These supermassive black holes are the gravitational anchors of galaxies, the quiet rulers dictating the cosmic dance of billions of stars. Their origin is still a mystery, a cosmic chicken and egg problem. Did they form first and galaxies grew around them, or did they grow with their galaxies? Either way, they are a fundamental part of the cosmic architecture, the dark hearts around which the universe revolves. For a long time, we believed black holes were eternal prisons. Nothing, not even light, could escape. They were the ultimate information shredders. If you threw a book into a black hole, the story it contained would be lost forever. This created a huge problem for physics, a fundamental conflict known as the information paradox. Our laws of physics say that information can't be destroyed, so where does it go? The brilliant Stephen Hawking proposed a revolutionary idea. Black holes aren't completely black. Due to bizarre quantum effects near the event horizon, they slowly leak radiation, a faint glow now known as Hawking radiation. This means black holes can evaporate, shrinking over unimaginable timescales until they vanish in a final burst of energy. But this only deepens the mystery. If the black hole disappears, what happens to the information it swallowed? Does it disappear too, breaking the laws of physics? Or is it somehow encoded in that faint radiation, scrambled beyond recognition? The universe, it seems, loves a good paradox. It presents us with these impossible questions that force us to rethink everything. Just as we were grappling with these theoretical nightmares, the universe gave us a new way to listen. In 2015, we detected something incredible: gravitational waves. These are ripples in the very fabric of space-time, created by the most violent events in the cosmos, like the collision of two black holes. For the first time, we could hear the universe. Imagine the sound of two cosmic titans, each weighing dozens of times more than our sun, spiraling into each other and merging into one. The gravitational waves they produce are a chirp, a rising tone that carries the story of their final, cataclysmic embrace. This discovery was more than just a confirmation of Einstein's theory. It was like gaining a new sense. We were no longer just looking at the universe through telescopes. We can now feel its vibrations. We can listen to the echoes of creation, the mergers of black holes and neutron stars, events that warp space-time itself. It's as if the world around you suddenly started to distort and bend, the familiar lines of buildings and streets twisting into impossible shapes, revealing the underlying, flexible nature of reality. We are just beginning to interpret this new cosmic music, and it is already telling us secrets about the dark side of the universe we never knew how to ask. So, what are black holes, really? Are they just cosmic vacuum cleaners, endpoints of stellar evolution, or are they something more profound? The paradoxes they present, the information loss, the singularity at their core, where our physics breaks down, suggest they are not just objects in space-time. They are clues about the nature of space-time itself. What if space and time, the very stage on which the cosmic drama unfolds, are not fundamental? What if they are emergent properties, like the wetness of water emerging from countless individual H2O molecules? Perhaps black holes are the seams in the fabric of reality, places where we can glimpse the underlying code of the universe. They challenge our most basic assumptions, forcing us to consider that reality might be a hologram, or that our three-dimensional universe could be a projection from a lower dimensional surface. They are not just celestial objects, they are philosophical questions written in the language of gravity. As we continue to probe these cosmic enigmas, we may find that they are not voids, but wombs, places where new universes are born, or gateways to other dimensions. The information that falls in might not be lost, but transcribed onto the event horizon, or transferred to another reality entirely. The quest to understand black holes is the quest to understand our own origins and our ultimate fate. They represent the limits of our knowledge, but also the frontier of our greatest discoveries. They are the darkness that holds the greatest light. So the next time you look up at the night sky, don't just see the stars. See the spaces in between. See the silent, patient darkness and wonder what secrets it's waiting to tell you. Because in that darkness, in those impossible points of infinite density, might lie the answer to everything. Thank you so much for joining me on this journey to the edge of reality. If you enjoyed this exploration of the cosmos, make sure to hit that like button and subscribe for more deep dives into the mysteries of our universe. Let me know in the comments what cosmic question you'd like to see us tackle next.